Welcome to the Microchip Is podcast. Join your host, Mike Maynard, as he learns about the technologies, products, and people that make Microchip technology what it is today.
Welcome to the Microchip Is podcast. I'm Mike Maynard, and today I'm talking to Dean Leo, who's the Industrial Marketing Segment Leader at Microchip, and he's explaining why Microchip is smart factories. Welcome to the podcast, Dean.
Thank you for having me.
Now, can you tell me a little bit about your role at Microchip?
Yes, I'm the Industrial Segment Leader, and we have segment leaders for all of the market segments that we're currently focused on. Our group works to understand the market segment to which we're assigned. That could mean anything from the customer's applications to the equipment that they're developing, problems that they're trying to solve. We have to understand the microchip technologies that can be the solution for those problems, maybe government regulations that are coming in the near future. And then we handle a lot of the communication that goes on between our business units, our client engagement teams that are focused on the customers, and also our executive leadership team.
So it's interesting, you're not the first person we've talked to from the segment marketing team. So, just so if people are new to the podcast, you don't actually, as a segment marketing team, make products, do you? You work with other divisions who make the products for the markets.
That's correct. And I see us as part of the conduit, the communication conduit between business units that do make the products and our customers who are being represented by our client engagement teams.
And I think most people who know Microchip are going to think of Microchip as being very strong in the industrial market. So, presumably the industrial segment is a hugely important segment for Microchip.
Absolutely. I don't think many people know, but industrial is our largest market segment. It's 32% of our revenue, which puts it at about $2 billion, depending on what point you're at in the market cycle. Almost all of the business units at Microchip have interest in the industrial segment, which keeps me hopping.
And that's interesting. So you're actually going around talking to all the different business units at Microchip and trying to help them build and grow that business within industrial. Is that right?
That's right. We work on client engagement guides for our field team. We put out knowledge-based videos that help them keep in tune with what's going on in the segment. We engage in field campaigns with some of the anchor business units. At Microchip, some of the top anchor business units would be the networking group, which has all of our industrial Ethernet products, including single pair Ethernet, time-sensitive networking switches. We have a field programmable group, which has FPGAs and SoCs for doing things like multi-axis motor control and smart embedded vision. We have microcontroller and microprocessor groups, everything from 8-bit to 64-bit, microcontrollers, microprocessors, digital signal controllers. And then we have a real leadership position in security. We have a security business unit that handles everything from authentication to secure boot applications, as well as encryption of data.
So that's amazing. You've got a really challenging job, like dealing with all these different business units, making all these different products that your industrial customers need. But also, presumably, you've got to deal with the many different facets of the industrial market, which is very broad as well. What are the most important industrial applications that you've been working on?
Yeah, the industrial market segment is very broad. You can almost look at it as a catch-all of anything that doesn't fall into the other segments falls into industrial. And some of my colleagues, actually, most of them, have business units that are dedicated to their exact market segment. So we've got an automotive products group, we've got a medical products group, we've got a data center business unit, a communications business unit, aerospace and defense. There is no industrial business unit. So I have to engage with all of them and with many of our client engagement teams out in the field in order to make things work. Some of my past focus areas have been in the areas of smart building, things like HVAC, security and surveillance systems. I've worked in power tools market segment. I handled the medical and fitness market segment for a while, smart grid, which you might also call power infrastructure. But recently, the last 3 or 4 years, I've been very focused on smart factory. And this is synonymous with what many people refer to as Industry 4.0. And the 4.0 refers to the fourth industrial revolution, if folks are familiar with that. And you might also hear this area called industrial automation.
And I think people would have worked out from the title of the podcast that probably we're going to talk about smart factories. But let's dig a little deeper into smart factory. When you talk about smart factories, can you talk about some of the things that you're doing to make factories smarter and better?
Yeah, one of the teams that I lead within Microchip is the IoT and edge computing megatrend team. And within industrial, there's a brand of IoT called Industrial IoT or IIoT. And in that role, I get to work with our cloud partners, folks like AWS and Microsoft Azure and Avnet's IoT Connect division. Edge computing is currently where it's at right now, bringing more processing power out to the edge. And this is enabling a lot of applications in the marketplace, like predictive maintenance, which is all about detecting equipment anomalies, often using sensors or data that's available within the system. This helps the factory avoid unplanned downtime, which can be really, really costly. Another application area is machine vision, where you're using video to identify defects that might be rolling along on a conveyor belt on the assembly line. You're working in that case to increase product quality and increase customer satisfaction with the product that they end up getting off the end of that assembly line. And another top area that we're working right now, and it's nice because there are a small number of huge companies working in this area, industrial robotics, fixed arm robots like you would picture in a large automotive factory. And with robotics, companies are working to improve worker health and safety. Often robots are, willing to do or brought in to do jobs that are either unsafe for a worker, or maybe over a long period of time, repetitive motion would damage their health. A robot can do this with no problem. And especially in the post-COVID area, where companies are now starting to think about things like illnesses and pandemics, deploying some robots, they're impervious to these human illnesses. However, they can be subject to computer viruses, so you do have to think about cybersecurity concerns when it comes to deploying robots.
Well, there's a lot there, Dean. I'm interested. You talked a little bit about AI, and I think this is one of the hot trends in smart factories is, bringing in AI. And you talked about compute being at the edge and being in the cloud. Can you just give a little bit of a description as to, really the benefits of either processing something in a data center or actually processing it at the edge right within the factory?
Absolutely. Edge computing is the hottest area right now, and the hottest technology within that is AI ML. At Microchip, we believe, and we all the customers that we talk to agree with us that there will continue to be a balance between cloud computing and edge computing. It's just more processing power is starting to migrate to the edge. Within the cloud, let's start there. Data centers, the big hyperscalers, even edge servers that you could co-locate in a factory location. They're such high power devices. And you see in the news all the time, companies like NVIDIA, every year they're coming out with higher and higher performance GPUs and products that can do this processing. This is enabling a lot of new applications. But on the edge side, there are many benefits. One of those is decreasing the latency. In cloud computing applications, you have to wait to send data to the cloud, let the cloud do its thing, and then the cloud responds with some type of an answer or a control signal. And a lot of applications can't wait that long. Many factory applications are down well under 1 millisecond control loop. That's for the entire control loop to finish. Also, it's very costly to send a lot of information into the cloud. Companies like AWS, Microsoft Azure, they make money by allowing you to bring those bits in, doing the processing, and then sending bits back out. And if you can decrease the amount of communication that you're doing, that lowers the cost of these applications, and you can do that processing on the edge. You can also increase the reliability of the application. If the cloud connectivity goes down, the more you're doing on the edge, the more of your application you've got left functioning when that happens. And you could also make a case that security increases when you do processing on the edge. The data often stays there as opposed to being sent into the cloud and gathered in one large location. A hacker gets in there, they've got a ton of data. It's really difficult for a hacker to get into all of the sensors and actuators that are out at the edge of a factory installment. So yeah, those are some of the benefits of edge computing. We also, to top it all off, we believe that the power efficiency that's involved is best when you're processing at the edge. That would be the watts that you're burning per transaction. Like in an AI ML case, watts per inference. In the data center application, I've heard that 40% of the data center's cost is in cooling the data center because of the amount of power that's going on within a small space. Out on the edge, you're using much more application specific solutions that don't have those kind of thermal issues.
Wow. So, I mean, that sounds like there's a lot of benefits at the edge. You get this better performance and lower power, which typically you either get one or the other. You don't get both, as well as all of the other things you highlighted. But I guess the problem is then you've got the system designers having to design this edge compute to be able to do all the processing at the edge. So, what are the challenges that electronics engineers face when they're trying to design solutions that will do the processing at the edge?
Yeah, it's about the balance that I mentioned in finding the right tool for the job. In a lot of cases, you're looking at how to make the solution as reliable as you can. I like to use the agriculture example where equipment is moving through a field and you've got camera systems pointed down at the ground and you're flying by at about 15 to 20 miles per hour looking at plants. And now the system must make instant decisions. Is that plant food that someone's going to eat later? Is it a weed that's a nuisance and should probably be pulled or killed? Do I need to spray water on this plant? Do I need to spray fertilizer on this plant to get it going along a little better? Do I need to spray weed killer on this plant? I don't want to do that on something that someone's going to be eating later. So there's really no time for the cloud to be involved in a situation like that, and that's where edge computing and high performance processing at the edge really comes into play.
That's interesting. I mean, the one thing I'm learning through this podcast series is Microchip has a massive range of products. So, can you just help me a bit and talk about some of those high performance products that can meet the demanding processing requirements of the edge? What are those products that Microchip produces?
Some of our highest performance computing products, some come from our field programmable business unit, like FPGAs. They also have system on a chip where RISC-V processors are integrated in with the FPGA. We have 32 and 64-bit microprocessors, full-blown microprocessors that can operate in a Linux environment. These, in some cases, have AI/ML vector engines built in. We've got versions of 64-bit with time-sensitive networking switches built in. The 64-bit family is very focused on post-quantum security, which will be very important over the next 10 to 15 years as quantum computing becomes a bigger and bigger thing. The current security systems and applications that we're using to secure these systems won't work against a quantum computer. And so whatever you can do now to design ahead against that post-quantum era will do you some good. And then if these are overkill for you, we've got the industry's only 8, 16, and 32-bit line of microcontrollers and digital signal controllers. And then around the computing, you can't forget the rest of the total system solution. There's the wired and wireless connectivity, security, as I mentioned. A lot of security applications require an external security IC for hardware-based security. You've got memory products, power management products, signal path like amplifiers and A to D converters, timing products. We've got it all. We've become a very broad line semiconductor supplier over the last 15 years.
That's fascinating. I mean, these products, they're doing things like processing, one or two video feeds each. Is that kind of the thing you're doing rather than aggregating it all up in the data center?
Yes, in the cloud, you can send in multiple video signals and get it all processed there. Out on the edge, you're typically dealing with one camera attached to one piece of silicon, whether it's an FPGA, a system on a chip, a 64-bit MPU, and you can process the video there in that one solution. There might still be communication with the cloud. You might have to alert the cloud of certain situations. Let's say something happens that the camera sees and they want to alert the farmer. It definitely needs that connectivity out, but it's about minimizing that interaction and the amount of data that you have to send and wait for.
And presumably as well, what Microchip's doing is helping getting that data to the edge processing. So things like sensors. Can you talk a little bit about your work in terms of enabling sensor networks and cameras and things like that to feed the data to be processed?
Yes, I don't know that many people know this, but Microchip has a sensor portfolio that's pretty rich. We have temperature sensors, we have inductive position sensors of many types in both those categories. We have power measurement ICs for single phase, three-phase power systems. But the sensors we don't have, we have very strong partnerships with other industry leaders. And we actually have a segment leader who is focused on maintaining that sensor partner program and being in a position to recommend certain sensor technologies when that's the driving force behind a customer's new design. The output of a sensor can be analog or digital, and we need to be prepared to handle either of those situations. In the analog situation, you want to take that signal and send it through signal chain products like amplifiers and A to D converters, and then into the compute engine. In the digital sensor case, typically the output will be something like I squared C or SPI bus, and you can send that directly into a microcontroller, a microprocessor, an FPGA. And once that sensor data is in the compute engine's memory, then you can start processing on it. And you might use it to do ML model selection. The way machine learning models are selected is you look at a bunch of good data and a bunch of bad data, and then you pick the model that classifies that correctly the highest percentage of the time. And then in runtime, you would use sensor data to do the inferences, the machine learning inferences. Or you might just compare the sensor data to hard-coded thresholds like you would do in a traditional design sense, the way things have been done in the past.
That's amazing. I feel like we've covered so much in terms of both technology and products in this discussion. It's amazing. It's clear Microchip is doing an awful lot in smart factories. We started off talking about one trend, which was edge compute. Are there any other trends you see in the industrial market or things that the smart edge is letting people do?
Yeah, absolutely. The hottest edge application right now is AI/ML, and industrial equipment needs real-time inferences and measurement. At the edge, doing these measurements on a single piece of gear can give you data that's unique to that specific equipment in that specific location, installed in exactly the manner that it's installed. And this makes any decisions that are determined by that specific systems special to that device. Some of the AI, ML, and edge computing technologies that are hot right now are encryption. There are greater and greater higher performance motor control protocols that are being handled. We've got over-the-air updates, things like digital power supplies, where you're using a microcontroller to increase the efficiency of the power management in your system, take it from 91% up to 96%, using digital power. Running protocol stacks on the edge. You see more operating system and RTOS use out on the edge now. And also applications for human machine interface, like graphics and touch applications that are improving the way that users work with these machines. All of those applications are being supported by edge computing and having more processing power at the edge.
That's great. I mean, it's amazing how moving that processing to the edge is changing the way people approach, how they build factories. What we like to do on the podcast is to, ask a couple of quick questions as well at the end. If you were talking to an engineer and they were working in the industrial sector, what's the one bit of advice you give them?
I guess I'd have a couple. One's a little bit self-serving. The first one, I would say Microchip, as I mentioned before, has become such a broad line semiconductor supplier in the last 15 years. I think understanding what we have as far as the number of solutions that we have as a company would be a challenge for any engineer. So I would recommend that they reach out to their local Microchip contact. We don't bite. We can definitely help, and we can bring in local subject matter experts. Depending on whatever your specific topic of interest is, we'll bring that right person in to have that discussion with you. Also, the general one that I would give would be, don't design in any new feature or new technology until you know that your customers value it. And I would say that some solutions seem expensive. Like I've heard customers say, "Oh, we've never used an FPGA before." Well, it really only seems expensive until you are able to unlock value in your customer's use case. If they're willing to pay you for that new feature, then those solutions actually turn into bargains because it helps you grow your revenues, increase your profitability, and in some cases helps your customer, mitigate their risks. in these applications.
I love that. I think it's interesting you're saying, use our products, but only use them when it benefits the customer because that will make you money.
Absolutely.
This has been great, Dean. I've really enjoyed the conversation. I feel like we've covered so much. I mean, is there something you could say to kind of summarize what you'd like listeners to remember about Microchip and smart factories?
Yeah, that problem that you're working on right now that you're trying to solve that seems unsolvable, for your smart factory customers, Microchip has probably seen it before or seen something like it before. Please bring us in early in those situations and let us help. That's why field personnel like me and your local Microchip contacts, that's why we exist. And we would to work with you on it.
Oh, I love that. It's a real challenge for listeners to bring some problems to Microchip and see if they can solve them.
Please do. Bring it on.
I'm sure people, who've listened to this would want more information. It feels like we've covered so much at a fairly high level. If listeners wanted more information, what's the best way for them to get that?
I'm on LinkedIn, Dean Leo. You can also reach me at dean.leo@microchip.com. We try to keep our emails pretty intuitive and simple. Also, if you're looking to understand Microchip's solutions for Smart Factory, about a year ago, we released a landing page, and it's also very simple to remember. It's microchip.com/smartfactory, all one word. And if you go there, it'll show you the 8 elements within Smart Factory or Industry 4.0 on which we're focused. You click on any of them, it's very interactive. You can look off to the right and it'll give you a list of Microchip solutions that fit, many of which I've talked about here on this podcast.
That's awesome. I mean, Dean, this has been great. Thank you so much for sharing your knowledge. And thank you for explaining why Microchip is smart factories.
Well, thank you, Mike, for having me. This was my first podcast, so I appreciate you being gentle. And I really enjoyed it.
Thanks for listening to the Microchip Is podcast. Please follow us on your favorite podcast platform to keep learning about the many technologies, products, and people that make Microchip what it is today. Look out for our upcoming Microchip Is podcasts and our new Beyond the Microchip podcast series.